Hi, my name is dr. Ahmath. In this video lecture, we are going to discuss about one of the most important topics in statistics, namely correlation and regression. Correlation is simply relationship between the two variables. We're often interested to know whether two things are related to each other and how they are related to each other. For example, you would be interested to know what is going to be your final score if you know your midterm score. So what do you think? So your midterm score is somehow correlated with your final score? And if yes, how? So I often ask my parents what was the money which they had before, like what was the salaries like 30 years or 40 years ago. And we often, when in our discussions, compare the salaries with the price of the bread or with the price of the bus fares. So it would be interesting for me to understand whether there is a correlation between the price of the bread and the bus fare. So I've taken an example from the statistics books, which is closely related to this example. So I would like to predict the cost of the subway fare from the price of the slice of the pizza. Don't you think that this example is going to correlate, is going to fit to our example with the price of the bread and the fares of the bus? I think pretty much. So by the end of the lecture, I would be interested to know whether it is possible to predict the price of the subway fare from the price of the slice of the pizza. So I'm going to express the plot of the ordered pair of data x and y using the scatter plot. So again, I would be interested to know whether x and y are somehow related. And one of the ways to see this relationship would be to sketch its graph. And the scatter plot is the best way to do that. So if you remember, the scatter plot is going to have x and y coordinates. So I've taken this table in order to show you, in order to remind you one more time what was the scatter plot. So I've taken the grades of students on Monday and the amount of the time which they spent in social networks and YouTube on Sunday evening. So this is going to be the number of the hours which they have spent in YouTube on Sunday, and this is going to be their scores on Monday's test. So I'm going to, so if I'm going to draw the sketch this, I'm going to have x and y coordinates. X is going to be, let's say, hours, and y, let's say, is going to be the test scores, and I'm going to sketch every point. So when x is equal to the 0, y is equal to the 96, so it's going to be somewhere here, for example. So this is going to be the score of the student A. When x is equal to the 1, it is going to be 85, somewhere here. When x is equal to the 2, it's going to be 82. When this is 3, this is 1, 2, 3. It is 74. Then whenever it is 3 again, right? So sorry. So student E is very smart, because even though he spent a lot of time by watching YouTube, his score is really good. So the student F has watched 5 hours in YouTube, and he's got 68. Okay, so I put these points, and this is called the scatter plot. I'm going to draw the ordered pair of data. So every data point is coming with its pair, right? So the amount of the hour every student has spent in social networks on Sunday and the score of student. Okay, so by just looking to this graph, to the scatter plot, I can clearly say that there is correlation. There is a relationship between the amount of the hour, the amount of the time you spend in social networks on Sunday and your test score. And you can see here, because the tendency is the following: as you are increasing the time you spend in social networks, your test score is decreasing. This is exactly what we would like to do, so without graphing. So usually you might have millions of data points, and we can't really just draw them and understand this by just graphs. So what we want is, we would like to figure out mathematical formulas or mathematical tools which clearly states whether there is correlation or not. In this case, there is correlation. As you increase the amount of the time you spend in social networks, your test score is decreasing. So we are going to differentiate different type of the correlation. So we are going to mostly discuss about the linear correlation in this lecture. So essentially, linear correlation means that two things are related to each other linearly by the scaling of some constant. okay? Or you can express this curves, all of the scatter, so it's points, just using one line, not a curves. So this kind of correlation, I would say it is called negative correlation. So we call that x and y are negatively correlated when one of the variables is decreasing when the another one is increasing. For example, here, x is increasing, right? You're increasing the values of the x, so going from the 0. And at the same time, the values of the y are decreasing as I'm increasing the x. So I say that x and y are negatively correlated. At the same time, this kind of scatter plot shows me that x and y are positively correlated. So when x increases also, when y is also increasing, so it means that x and y are positively correlated. You can see here that as I'm increasing the x, so I'm choosing the values for the x bigger and bigger, the values of the points, the y values of the points are also increasing. So this means that, or this graph shows that the x and y are positively correlated. This is what we call as a positive correlation. So at the same time, you might have this kind of graph where it is difficult to trace the correlation between the two variables. I would say that there is no correlation. For example, the best example of no correlation would be your score or your grade from history and statistics. So probably there's no correlation. Even though you get really good score in statistics, I don't think that it is going to make your grades and history really good as well. So sometimes we're going to have so-called nonlinear correlation. So when x is going to increase, so as you are going to increase the x, y is going to increase up to some point and then start decreasing. So one of the good examples for this kind of nonlinear correlation was given by one of students. He told me that x can be the amount of the hours you sleeping hours before some exams, and this is going to be your exam score. So let's assume that if you're going to sleep less, for example, 1 hour or 2 hours, then your test score is not going to be probably good. And as you are going to sleep well, your test scores are also going to tend to be better and better. For example, if you sleep 7 hours, then your test scores is going to be really good. But at the same time, if you're going to sleep more, maybe like 13 hours or 15 hours per day, it means that you became super lazy and probably your test scores are not going to be good. So the amount of the time you sleep per night and your test score has the correlation, and probably it is going to have a non-linear correlation. So what we are going to do in this lecture is we are going to try to measure the linear correlation between the x and y. If there is linear correlation, we've been able to track that. So we're going to do this using one number that is going to be called as the correlation coefficient. So we're going to get all of the points from the x, and we're going to get all of the points from the y, put this into some sophisticated formula, which is going to give us just one number. And this number is always going to be between -1 and 1, and depending on the values of this number, we can figure out whether there is a correlation, linear correlation, or not. So if the value of the r is closer and closer to the 1, it means that there is a strong correlation, and this correlation is positive. And if the value of the r is becoming smaller and smaller, so closer and closer to the -1, then we still say that there is a strong relationship between x and y. So if you change the x a little bit, y is also going to be changed. But this correlation is going to be negative because r is negative. So whenever we've got no correlation or nonlinear correlation, r is probably going to be very close to the 0. So let's do an example. So what I want is, I would like to calculate the correlation coefficient for the following data. If you remember our first example, I would like to understand whether there is correlation between the amount of the price of the subway fare, so the ticket for the metro, and the cost for the pizza. So here are the prices for the 1960s, 73, 86, 95, 2002, and 2003. And if you remember, the correlation coefficient has a bunch of things inside. So I need to do the calculations of all of these things. So here I have to multiply every point x and y Then I need to sum all of the x's, sum of the y's. I need to find the sum of the x in the square, sum of the y in the square. Probably I need a bunch of other table with lots of other rows, and I have to do all of this together with you. So first thing what I have to do is I need to multiply x and y. So in this row number 3, I'm going to write down the multiplication of x and y. It's going to be 0.15 in the square. So it's going to be 0.35 in the square. It's going to be 1.25 times 10 to the 1.35, 1.75 times 10 to the 1.5. It's going to be 4. Easy. So for the x in the square, I'm just going to get every point from the x and just square this. For the first 3 columns, it is going to be similar or the same. It's going to be 0.15 in the square, 0.35 in the square, and 1. And for the next one, it's going to be 1.25 in the square, 1.75 in the square, and 2 in the square, which is 4 again. And then I'm going to do the same thing for the y. I take every value for the y and just square this. It is going to be 0.15 in the square, 0.35 in the square, 1.35 in the square, 1.5 in the square, and 4. So what I have to do is, if you see, I need a sum of all of the x and y's. So this is the row with all of the multiplication. This is actually the vector, right? Or the array with 6 entries. So all of them contains the corresponding multiplication of the x points to the y points. I need to sum all of them. So I'm going to add one more column at the end and just find the sum of all of the x's, all of the y's, all of the xy's, all of the x squares, y squares, and then put them together into this formula. And if I put this, I'm going to get the following values. So n is the number of the points, which is equal to the 6 in our case, multiplied to the sum of xy. So sum of xy is 9.45. So 9.46, I would say, 9.46 minus the sum of the x, which is 6.5, times the sum of the y, which is 6.35, well, divided to the sophisticated formula n, which is 6, times the sum of the x in the square, which is 9.77, minus the sum of the x in the square. It's going to be 6.5 in the square. And then I have to do the same thing for the y. It's going to be n, which is 6, times the sum of the y in the square. It's 9.21 minus sum of the y in the square. It is going to be equal to the 6.35 in the square. So probably you need a good calculator in the exam in order to do all of these calculations, or you can use some other online tools like Google Sheets or Microsoft Excel in order to do these calculations. And if you put together all of these numbers, you're going to get the value for the r to be equal to 0.98 and 8. So 0.988. So which means that the value of the r is really close to the 1. There is a strong correlation between x and y, and between the cost for the pizza and subway fares. So by just understanding how the price for the pizzas are changing, you can understand how the ticket prices for the metro is going to be changed. For example, by just understanding, mapping this example into our country. So by just understanding how the price of the bread is changing, you can understand how the fare prices, how the bus fares are going to change. So what I would like to do is I would like to understand some values. If you remember, we discussed about the values of the r. The r is going to be just one number. Even though you've got million of the points, you're going to summarize them together, right, into this kind of huge table, and you can make the calculations of the r, which is going to be just one number. So if this number is negative, but it is really close to -1, it means that you've got strong negative correlation. And you can see here that for this example of the scatter plot, for this SAD, so the correlation coefficient is -0.91, which is clear, which is obvious that it has this strong negative correlation. As x increasing, y is decreasing. At the same time, for this example, r is equal to 0.88, and you can see here that there is strong positive correlation. As x increasing, y is also increasing. At the same time, this correlation coefficient is not able to track a non-linear correlation. Even though sometimes if x and y have the correlation, so are related. If you're changing the x, y is also going to be changed somehow. But if this correlation, if this relationship is non-linear, this correlation coefficient is not going to be able to track that. For example, for this data set, so we can see from the graph, from the scatter plot of this data set, that they are correlated. And I would say that they are really strongly correlated. But even though r is going to be equal to the 0 or close to the 0, because it is not able to track that nonlinear correlation. Well, today's lecture, we're going to concentrate mostly on the linear correlation. So, okay, so the natural question would be, so we've got the value of the r differently. For example, I've got an example with the value of the r 0.988. Sometimes we've got 0.88. So what we say, what is that threshold when bigger than threshold, the r is going to be called as the strong correlation or not correlated. So what I say when the r is close to the 0 or close to the 1. So is there any measurements for that? Well, in the book, there is given the thresholds for the r, for this coefficient of the r. So it is say that if the value of the r you've calculated is bigger than 0.81 or smaller than minus 0.81, then in that case, we're going to say that data points x and y are strongly correlated. So any value of the r in between these two values, so here between minus 0.11 minus 0.811 and plus 0.811 would be say that there is no correlation or weak correlation. For example, if the r would be equal to the 0.65, then we would say that there is weak correlation or there is no correlation. But for our example, the r was equal to the 0.988, I would say that they are strongly correlated. Well, that's the correlation coefficient. And we've calculated this for our example with the price of the bread and price of the fares for the buses. Let's do one more example. So the following data represents the number of the hours of 12 different students watched TV during the weekend and their scores on the test on Monday. So I would say nowadays people, or especially young people, do not watch TV. So I would just substitute this watching YouTube or some other social networking platforms. And then, so it is going to be their scores on the test on Monday. So this is what we had in the beginning of the lecture. So this is going to be the data for the student A. This is going to be the data for the student B. This is going to be the data for the student C, and so on. So basically, the A comes with a pair of numbers, 0 and 96. It means that the student A didn't spend any time, 0 hours, by watching YouTube, and his score is 96. So what I want is, I would like to first of all sketch the scatter plot for this data, and then calculate the correlation coefficient and try to understand whether there is correlation or not. So the scatter plot is going to look like this. So probably you can see here that there is correlation between x and y, and there is negative correlation. We've seen this in the beginning of the lecture as well. So as x is increasing, as the amount of the hours students spend by watching YouTube, their scores tend to decrease. And I would like to understand exactly what is that correlation coefficient. Obviously, I'm not going to be able to do all of these calculations manually. So it is better for us to use some online tools to perform all of the calculations. And now let's do this in Google Sheets. I'm going to copy all of this data into Google Sheets and try to calculate the correlation coefficient. Well, here is my data for the x and y. And if you remember, in the correlation coefficient formula, I need x multiplied to the y. So here I'm just going to type equal, so this cell from the x times the cell from the y. And it's going to be 0, and I'm going to extrapolate this formula for all of the points. So here I have to multiply x to the y. X to the x itself, sorry. So x multiplied to itself, a2. And then I'm just going to extend this formula to other cells. And I'm going to do the same thing for the y in a square. So it is equal to y multiplied to the y itself, and then I'm just going to extend this to all of the rows for the y. Good. And now I have to find the sum of these columns. So I need to sum all of the values of the x from A2 until A13, and close the brackets and press OK. And I have to do this for other cells as well. Okay, so I've got all of the sums. And if you remember, I need to now do the correlation coefficient calculation. It is equal to, so the fraction, right? So I'm going to write down the brackets for the numerator. It is n, which is 12. We've got the data for the 12 students, times the sum of the xy. This is the sum of the xy, minus the sum of the x, multiplied the sum of the y. This was the numerator. I'm going to close this, and this is divided to, in the denominator, I've got the square root of n, so 12 times to the x squared, which is 332, minus the sum of the x in the square. This is 54 times t itself. I'm going to close the square root, multiply to another square root of n, which is 12 here, multiplied to the y squared, which is this number, minus the y in the square, y, times the y, the sum of the y's in the square. I'm going to close the brackets for the square root, and I'm just going to press OK. It is going to be minus 0.831. So this is how we can do the calculations for the correlation coefficient if you're given the data set. Well, instead of using the manual calculations with a bunch of calculations, we can just use the online platforms like a Google Sheets in order to perform these calculations. So we've got the value for the correlation coefficient minus 0.83. So according to our theory, so there is correlation, there is strong negative correlation. It means that as the number of the hours you spend by watching YouTube, your scores on exams tend to decrease. Good. So this is what is the correlation. What I would like to do is I would like to extend this in so-called regression line. The regression line, which is also called as a line of best fit, the line which shows that which is going to fit to our data really good, so that it explains our data, and also it helps us to predict the data. For example, if you remember, so we used to have the x-axis and y-axis, and we've tried to relate, or we tried to give some meaning for the x and y. For example, we used to have the example was the number of the hours spent in watching YouTube and the scores, right? Scores of the exams. Scores of the exams, and let's say you are given 2 points. So for example, for the student who spent 2 hours and for the student who spent 4 hours. Well, I don't think that it is going to represent represent this data very good with 2 points. But again, so I would like to understand, so if I would spend 6 hours, what would be my score? Right? In order to do that, one of the good ideas would be to just make a line which is passing through these 2 points. And if I would just give some point, for example, 6 to this point, I would just find its y coordinate, because I would just know the equation of the line. So the line equation is going to be kx plus b. So the idea of a regression line is to express all of the points using just one line. And this line is going to explain us, for example, first of all, the relationship between the 2 variables, and at the same time, it helps us to do the predictions. Because so if you don't have the data for some values of the x, you can just generate those points using this line. Well, if you've got just 2 points, you can always make a line through the 2 points. But what if you have more points? So how to make the line? So it is obviously that it is not possible to make a line which is a straight line, which is passing through all of the points. So what we would do is we would sketch a line which fits to our data in the best way. And what we say by fitting in the best way is that the distance between total distance between all of the points. So this is going to be the distance 1, distance 2, distance here, and distance 3 here. It's going to be simply 0. Distance 4 and distance 5. So the sum of all of these distances, the distance 2 and distance 1, is going to be minimized. So if you remember, the equation of the line, of any line, is given as the kx plus b, where k is going to be the slope of the line. So you're going to control how much your line is sloped, and b is going to be called as the y-intercept. So what is the height of your line? So every line has two parameters. So you can choose the parameters of the line in such a way so that the total distance, the sum of all of the distances from the line to the points, is going to be minimized. So that's an optimization problem. We can solve this differently. So we used to solve this problem in calculus. So there was a video lecture with the discussions of this problem. And also we used to discuss this problem in linear algebra as well. So this is so-called least square approximation as well. So what we want is we would like to now just use the formulas to calculate k and b if you're given the data set. So but this is what does it mean, the regression line. So if you are given the data points, again, so the x points and y points, so x and y are coming as a pairs, then you can just substitute the values of the x into this formula of the k, and into this formula of the b, calculate the slope and the y-intercept of the corresponding line. So if you remember the formula for the regression, for the correlation coefficient, so the correlation coefficient formula is very much close to the k, to the slope of the line. So you can understand the correlation coefficient as the slope of the line, which would explain the data sets, right? So if you remember, this data has the slope to be equal to the 1, right? So the correlation coefficient can be understood as the slope of the regression line as well. So please note that whenever you take a sum of all of the values of the y and divide this as the number of the points for the y, it is nothing else as the average value of the y. And whenever you take the sum of all of the x's and divide this to the n, this is nothing else as the xn. So this formula for the y-intercept can be simplified to the y bar, minus kx bar. So let's do the calculations. So I'm going to do the calculations for the same students. So I've got the data for the students. We've calculated previously that there is correlation between them. So what I want is, I would like to know, so if one of my students spent 9 hours by watching YouTube on Sunday, what would be his score? Right? So that's the question. So I know that there is a relationship. I would like to figure out what is exactly the relationship between the amount of the hours you spend by watching YouTube and your score. In order to do this, I'm going to do all of the calculations, put everything together. So you can do this in Google Sheets one more time. So the equation for the slope is going to look like this. N here is going to be equal to the 12. So the sum of the x and y's is equal to 3,724. If you remember, we did this previously in Google Sheets. And so sum of the x's is 54, sum of the y's is 908. The n is 12, sum of the x in the square is 32, sum of the x 54 in the square. And if I calculate this, I'm going to get minus 4.067. So I'm going to find the average of the x. So I have to divide 54 to the 12. This is going to be divided to the 12. So the sum of the x is equal to the 54. This is divided to the 12 is going to give me the x bar. So sum of the y is equal to the 908 divided to the 12 is going to give me y bar. And I'm just going to use these two values to evaluate the b, the y-intercept. The b is going to be the average value of the x, which is the x bar, minus the k, which we've calculated, which is minus 4.067. Which is the k, multiplied as a y bar, and if I calculate this, it is going to be 93.93. Well, the regression line is going to be in the form of minus 4.07, x plus 93.97, actually, 97. So what does it mean? It means that the score of a student is going to be equal to minus 4.07 times the amount of the hours he spent by watching YouTube, plus 93.97. Well, if I would like to know what would be the score of a student who spent 9 hours by watching YouTube, I would just substitute here 9. And if I substitute the 9 here, or 8, sorry. So probably it should be 9. And if I substitute the 9 here, it's going to be minus 4.07 times the 9 plus 93.97. It's going to be 57.34. So it means that I can figure out the score of a student by knowing the amount of the hour he spent. So we've been able to do this by understanding that there is correlation between X and Y. And then we've been able to do this by deriving the regression line. Well, this is what I wanted to discuss with you. Thank you very much for your attention. I hope that this was helpful for you.